Welcome back. 7.2 compound interest. Compound interest is the interest that's used by all of your banks and credit card companies these days. They don't use simple interest. Compound interest is a manipulation of the simple interest formula so that it is many simple interest calculations together. Because normally you don't get interest every year. It's usually more than once a year, whether it be 4 times a year or monthly or 12 times a year or daily. It's different than just yearly. Simple interest is a nice, easy way to calculate a ballpark of what you could owe, but really it would be based on a compound interest formula. There are two types of compound interest formulas. There's two compound interest formulas. One, if the annual interest rate, or if the compounding period is an annual compounding period, which means once a year. Or you can have non-annual, which would be different times a year. And we'll talk about that when we get to that example. And the formulas change, or the formula changes slightly from here to there. So with compound interest for an annual compounding period, our formula is A is equal to P times 1 plus I, which is our interest rate, times T, which is or not times T, to the power of T. A is the amount of money you have after however many years. So this is inclusive of the interest, unlike our simple interest formula. So this is our principal plus our interest. P is our principal. I is our annual interest rate, and again, as a decimal. And T is our time, again, in years. So much of it's the same, a little bit different. Example 1, calculating the amount for an annual compounding period. A loan of $5,000 is taken out for 4 years at an interest rate of 10.75%, compounded annually. So this is the phrase that you're looking for, compounded somehow. So compounded annually. What is the amount of the loan at the end of 4 years? So we know our formula is A is equal to P1 plus I, all raised to the power of T. And again, if you want to, you can start listing out what you have. Well, I know my principal is $5,000. I know my interest rate is, what was it, 10.75? 10.75, which as a decimal would be 0.1075. My time was 4 years. And we can put that into our formula. 5,000, 1 plus 0.1075, all raised to the power of 4. Simplify the bracket a little bit, 5,000, 1.1075, all raised to the power of 4. Remember, I have to do exponents first, so I got to work out that part. And then when you multiply by the 5,000, you get $7,522.20. Okay. Now, this formula changes if we have a different compounding period. And I'll talk about the compounding periods in a moment, okay? But really, it's how often you get interest in a year. And because compound interest is interest on top of interest, it could make a significant difference in the amount of money that you'd have at the end. So here's our formula. A is still the amount of money that we have in the end, or owe in the end. It's a loan. Principal is the amount of money we start with. R is our interest rate divided by N, the number of compounding periods, raised to the power of N, our compounding periods, times time. Okay, so our formula is a little bit more complicated. And now the compounding periods can vary. In an annual, compounded annual, it's 1 compounding period. You get interest once at the end of the year. Semi-annual would be every 6 months or twice a year. Quarterly, like it says, is 4 times a year. Monthly would be 12 times a year. There's 12 months in a year. Bi-monthly would be every 2, it would be 2 per month. 2 per month would be 24. 2 times 12 is 24. Weekly, there's 52 weeks in a year. Bi-weekly would be every 2 weeks. So it would be 26. and daily, 365. Okay, so those are the different types of commonly used compounding periods. Let's look at an example. A principal of $4,500 was invested in a savings account that pays 2.25% interest compounded quarterly. And again, there's our phrase. That's what we're looking for, compounded quarterly. What is the amount in the account after 3.5 years? Here's our formula. Here's A. A is equal to P bracket 1 plus R over N and T. My principal is $4,500. 1 plus my interest rate as a decimal, 2.25 would be 0.025. 225, sorry, 225. 0.0225 all over, we're compounded quarterly, 4 raised to the power of 4 times, how long is it in for? 3.5. Now notice I put my exponent thing in a bracket because I have to do that math before I raise that thing to the power. Otherwise, it'll be in your calculator, but your calculator won't be doing what it needs to do. So if you punch this in your calculator, kind of as it's written, you'll be totally fine. Otherwise, do some individual steps, do this math, get some numbers, raise it to the power and multiply, but you should get $4,800, 4867, 63. And oops, 1 line and a dollar sign. Question B. Suppose you need to save $5,000 to buy a car on your 21st birthday in 5 years' time. You find an online investment that pays 4.15% interest, compounded semi-annually. What principal do you need to invest now? So again, I'm going to start with my formula. And fill in what I have. I know that I need $5,000 at the end. My principal, I don't know. My interest rate was 4.15%, so 0.0415 divided by N. Semi-annual was 2, all raised to the power of 2 times how many years? 5 years, right? 5 years. Yeah, 5 years time. Oops, I don't know what happened there. Come on. 5,000 equals P times all of this worked out. I got a value of 1.227987. To get P by itself, I'm going to divide by 1.227987, divide by 1.227, whoops, not 97, 7987. And I'll go over here, run out of space. I got 4,071.70. So you would need to invest $4,000 right now at 4.15% compounded semi-annually to have $5,000 at the end of the 5 years. Okay. Over the page, example 3. Calculating the interest and the interest rate. A principal of $1,000 is invested for 4 years at an interest rate of 10.2%, compounded weekly. Calculate the interest earned. Calculate the interest earned. We know our formula for compound interest, and I have to use compound interest because it says compounded weekly. If it says the word compounded, you're not going to be able to use simple interest. Okay, so compound interest. So this is A. A is equal to P bracket 1 plus R over N and T. My principal is $1,000. 1 plus my interest rate was 10.2, so 102 over compounded weekly, 52 weeks in a year, raised to the power of 52 times 4 years. 4 years. Punch that into your hand again. Calculator, that tells you 1503.21. But that's the amount of money we have at the end. That's not the interest earned. To calculate the interest, I'm going to go, so remember that amount is equal to my principal plus interest. So if I have my amount, which is 1503.21 is equal to my principal, 1,000, plus my interest, I can subtract 1,000 and get $503.21 is my amount of my interest. Okay. Question B. Question B, a principal of $5,000 is invested for 5 years and earns interest of $12.35. The interest rate is compounded monthly. Calculate the annual interest rate to 2 decimal places. So this one's going to be a little bit trickier because we have to calculate the annual interest rate. Okay, so let's go B. And I know I'm going to blow this up. A is equal to my principal times 1 plus R over N and T. I know my amount. Well, I don't know my amount, do I? But I know that I started with $5,000 and I made $12.35 interest. So my amount is $62.35. $62.35. My principal, 5,000. 1 plus my interest rate was, oh, I don't know. That's what I'm looking for. R over compounded monthly, 12. 12 times how many years? 5 years. And I'm going to move this a little bit. It's kind of in my way. There. So what can I do here? I can do my 12 times 5 is give me 60. So let's do that. 62.35 is equal to 5,000 times 1 plus R over 12 to the power of 60. Well, this is 5,000 times this, and this is all one thing, right? This is all one thing over here. So that's 5,000 times that. So I should be able to divide this side by 5,000, divide this side by 5,000 to simplify both sides a bit. 62.35 divided by 5,000, 1.247 is equal to, those will cancel, 1 plus R over 12, all raised to the power of 60. Now, what we've done in the past is, so we've seen questions like this. 4 is equal to x squared. How do I get x? I take the square root of x, square root of 4, that gives me 2. Except now we're not raised to the power of 2, are we? We're raised to the power of 60. So I should be able to, let's take a different color pen, take the 60th root of 1.247 is equal to the 60th root of this. And I would get the 60th root of 1.247. Where's my number? 0.0036857 is equal to the 60th root of something raised to the power of 60. Those will cancel. 1 plus R over 12. And if I continue to solve for R, I'm going to subtract 1. So this is 0.0036857 is equal to R over 12. Multiply by 12. Multiply by 12. That gives me 0.044229 is equal to R. That's as my decimal. So I multiply that by 100 to get my interest rate, 4.4229%. and then round it to whatever, 2 decimal places, 4.42% interest. That's one of the tougher types of questions because there's lots of working backwards in there. Over the page, this little rule of 72, is a simple little rule that allows you to calculate the time in years for any kind of investment to double. And it's an approximation. You simply take 72 and divide it by your annual interest rate as a percent, not a decimal. Question A, determine the number of years it will take to double an investment when it earns interest at 6% compounded annually. Number of years is equal to 72 divided by my interest rate, which is equal to 72 divided by 6, which is equal to 12 years. Approximately. Put the approximate sign, approximately 12 years, because it's an approximation, it's not exact. Question B, suppose you leave high school at 18 and you have saved $5,000. You want to have $20,000 by the age of 30. What average annual interest rate do you need to achieve your goal? And is this rate likely? Question B. Question B, you have $5,000 right now, and you want to end up with $20,000, which is a couple of doubles, right? 5,000 to 10,000, 10,000 to 20,000. Well, how long is it going to take $5,000 to double? And then how long is it going to take $10,000 to double? And you have to do this from the age of 18 to 30. 18 to 30, that gives you 12 years. I have a total of 12 years. So I need this to go from $5,000 to $20,000 in 12 years. That means every 6 years it has to double. So now in 6 years and in 12 years it has to double. So now we have some values. We can consider our rule of 72. 72 divided by my percentage is equal to my time in years. Well, my time for it to double is every 6 years. So 72 divided by my percentage is equal to 6. How do I get my percentage? Let's change. Let's work this out. 72 over my interest rate is equal to 6. So we've done many calculations like this before. A couple of ways you can do it. What I've shown you many times. Make this a fraction. Flip both sides. R over 72 is equal to 1 over 6. And now I can multiply by 72, multiply by 72. R is equal to 72 over 6, which is equal to 12%. Is it likely that you're going to find an interest rate for some kind of savings account or investment to give you 12% return? Not so likely. If you did, if we did, if we could, if I knew of it, I wouldn't be working here anymore. I'd be investing my money. I think that takes us to the end of 7.2, compound interest. We will see you next time.